let's take example of S2 first. Okay, start from the easier one. S2 has number of elements as 2 factorial, that is equals to 2 only. How to define those elements? So S2 is a symmetric group of order 2 factorial, and it is the group, like basically symmetric group based on the set basically 1 and 2 only. Okay, now we will see like how to get the elements of S2. So let's just have the mapping as 1 2 1 2. Okay, so basically permutations are what? Are the functions. Functions are what? Basically mapping, okay, from this group, basically from this set to itself. Okay, so there are like we will see the possibilities of mappings, like how we can map these elements to these elements. Okay, the first possibility is like we have mapped 1 to 1 and 2 to 2. Okay, so it is like we have mapped 1 to what? 1, 2 to 2. So first case is this. Okay, now let's second case, how we can map elements. Second possibility is we have mapped 1 to 2 and 2 to 1. Okay, 1 to 2 and 2 to 1. Yes, so these are the only two possibilities of mapping these two elements, such that these mappings will become bijection map. Okay, because we have to consider the fact like permutations are not just the mappings, they are the bijection mappings. So this particular case, when the element is mapped to itself, like 1 is mapped to 1, 2 is mapped to 2, is called identity, and second case is like 1 to 2 1. Next we can write these permutations in the form of cycle notation. And cycle notation is nothing, just what, like we have mapped 1 to 1, 2 to 2, so we can just write it as this only. Okay, next we have 1 to 2, 2 to 1. It's like 1 is mapped to 2, 1 is mapped to 2, and 2 is mapped to 1. Okay, so this is the cycle notation of this element. So basically S2 has two elements, 1 and 1 2. 1 represents identity and 1 2 represents the second notation. Okay, next we'll talk about S3.